Hi, Jake. I want to walk you through the two questions you sent me. The one being the disease that's happened that has an incidence rate of 0.4%, false negative of 4%, false positive of 4%. So I calculated it out here, and I just kind of want to show you the math of how I did it. So the best way to organize these kinds of things is to make a table where basically I say you have the disease or you don't have the disease, and that the test shows that you had a positive or a negative. Okay, so the next thing you need to do here is you just need to make up some number. I usually like to try to pick a really big number so that I'm not dealing with really weird things. So I just picked the random number of 100,000. Okay, so with 100,000, then what I know is that if the disease has an incidence rate of 0.4%, the very first thing I do is I take the 100,000 times 0.4%. So that would be 0.004 in the calculator. And if I go over to my calculator here, 100,000 times 0.004 gives me 400. That 400 I then put right here. Okay, so now with that, the second step to this would be that of those 4% that then have it, there's a false positive rate of 4%. So, in other words, I want now 4% of this 400. So here's my 400 times 0.04. So it's going to be 400 times 0.04 is 16. That 16 I filled out right here. If this is 16 and this is 400, then I know this to be 384. Okay. Now, let's then look at what we know next. If there's 100,000 people and 400 have the disease, then the remainder, 99,600, don't have the disease. Okay, so now I know that this is 99,600. Now, the next part to this would be is that we have false positives, and that the false positive rate is 4%. So now 4% of 99,600 is 3984. That goes right here. So now I should be able to add up 384 and 3984 to get this 4368. If I know that this is 3984 and that this is 99,600, 99,600 minus 3984 will get me 95,616. Now the ultimate question here is, what is the probability that a person who tests positive actually has the disease? So that a person who tests positive actually has the disease. That would be 384 over the total number of people that test positive, 4368. Which gets me 0.087912088, which I believe is the correct answer. So that walks you through how to do that. It's a very good general step, though, because you're going to see the same thing on the exam. Let's talk about the other one that you had. 34% of people own dogs. If you pick two people at random, what is the probability that they both own a dog? In this case, you can just take the 0.34 times 0.34. And you should get about an approximate 11.56% chance that both people would have a dog. It says round to at least 3 places. Um, 0? I don't know. It's just round. Okay, so there you go.